So meaning of uncertainty in machine learning. The uncertainty in general terms, uncertainty means something that is not certain. Outcome is not fixed. That is uncertainty. We don't know like what will happen next. Uncertain. But what is the meaning of uncertainty in machine learning? Let us try to understand that. That is more important for us. So to understand uncertainty in machine learning, let us take a look into a example of spam classification. So spam classification. So the idea is that if I talk about an email, email can be a spam or not a spam. So a spam classifier, what it can do, it can take any email and it can classify it. It can classify it whether that given email is a spam or not. So that is spam classification. So now here, the idea is in order to train a model, definitely the scope is all the emails in the world, all emails in the world. That is the scope. Now, definitely, see, the idea is that while training a spam classifier, we cannot consider all emails in the world. That's not feasible. Even companies like Google or Meta, with such a huge infrastructure, even they cannot consider all emails in the world while training their model. So there is a constraint. There is a constraint. When we will be training our model, we will be using a subset. So the training data set, let us suppose we are taking 10,000 emails. So what we are doing, we are basically sampling. We are sampling. And what is sampling? From the population. And population here is the all emails in the world. We are preparing a sample. We are choosing 10,000 emails. And that will be our training data set. And we will train our model using this training data set, using these 10,000 emails. Now here, some important observations we have to make. The first important observation is that whatever training data we are taking, so that is incomplete. Data is incomplete because we already saw we cannot consider all emails in the world to train the model. Rather, we have to take a subset of it. So ultimately, the data set will be it will be incomplete. It is just a sample of reality. It is the sample of reality. Now see, and why it's problem. See, the idea is that artificial intelligence, or if we are making a classifier, it is all about classifying patterns. Like a email with a spam or a spam email will be having certain patterns. And if I recognize that pattern, if I learn that pattern, then very easily looking at any new email, I can say, or my AI model can say, it can predict, it can classify whether it's a spam or not a spam. So it's all about pattern recognition. Now the problem is that if we are just choosing 10,000 emails, a subset, a sample, the problem is that so many possible spam patterns we missed. And that is what is data is incomplete because so many spam emails we haven't taken into consideration. So our AI model or our machine learning model, our classification model, it will be unaware of those patterns. It will be unaware of those patterns, because of which what will happen, its accuracy will suffer. So here one very important observation we made, the data is incomplete. Second important observation that we can make is data is noisy. Data is noisy means whatever training data we are having, it might contain some error. And what error here we can have? Wrong classification or wrong labeling. I'll tell you. See, the idea is that in training data, you already are aware of this concept that in training data, we have both features and the target. So features, let us suppose we represent it with the X and target is the Y. So we label the feature in training data set. So in training data set, I know both input and output. I know that, okay, if these are the features, then this should be the target. And in spam classification, Y can take only two values. Either the email is spam or not spam. Now see, what is the idea is that, let us suppose I take feature X. It's a vector. It can be collection of features, like some specific keywords might be there. These are like the things which help us in predicting whether email is a spam or not. So these are like features. So in training data set, I have both input and output. I have that information that, okay, if these are the features, then it has to be a spam. And if these are the features, then it is not a spam. So labeling is there. Labeled data I have. That's a training data. Now, what is the meaning of data is noisy? Data is noisy means there might be some human error or some other sort of error, because of which, if for a particular email, the features are corresponding to not spam in reality. But in while preparing the training data, we labeled it as spam. So here we made a very big mistake. And here we introduce the noise. Here we introduce the noise because email with not spam feature, we labeled it as spam. Now our ML model will get confused. How it will get confused is that it will take into consideration those features, and it will assume that, okay, these features are leading to spam. But in reality, those features are leading not a spam. So here we introduce a noise. So this is one example. Other examples may be in the feature itself. Like feature, we know that multiple attributes might be there, features. So there in itself, there might be some error, some missing values might be there, some error might be there, some inconsistencies might be there. So all those are noise. So unfortunately, whenever you are building a AI model, you will be dealing with data. And no matter what, no matter how good, like you are very cautious, still you can make mistakes. Noise is something which is unavoidable. So data is has to be noisy. Like we can't do anything much in that. So two important observation we saw, like whatever training data we have to train our classification model, the data is incomplete, the data is noisy, the data is biased. Now what is the meaning of this? The data is biased. So the idea is that, let us suppose 10,000 emails I have. Now in this 10,000 emails, it might be a scenario that 8,000 emails are not spam. Like, like in this training data, 8,000, I have 8,000 emails which are labeled as not spam, and 2,000 emails I have which are labeled as spam. Now, what problem will occur, or like what's the problem with this is, when you will be training the classification model, it will have more information about not spam, because 8,000 uh, observations will be not spam. So it will learn not spam more accurately as compared to the way it will learn the spam. So that is what we call is data is biased. The data is biased towards not spam. So that's the that might be the scenario. It happens because, let us suppose you are conducting a survey to collect the data. Now in that survey, if let us suppose 80% women participants are there and only 20% male participants are there in that survey. So automatically that survey is biased towards women, because whatever opinions or whatever the data it has captured, it is inclined towards women mindset, because more than 80% participants were women. So the data is biased. So data is biased. So this biasness can have very bad impact on the AI model which you will be building. So in the real world scenario, the data is biased. Now with all these shortcomings, we can say that whatever predictions our AI system will make or our machine learning model will make, those predictions will not be 100% accurate, because those predictions cannot be 100% accurate, because the data used to train the model is incomplete. It does not have all the patterns. So if it gets a completely new kind of a email which the model has never seen before, it might have some very different patterns which is missing in the training data, then definitely it can make big mistakes in making classification. So now it's very clear that whatever AI system we will be making, AI model, ML model, they cannot be 100% accurate. 100% accuracy we cannot get because of these constraints. Noise is there in the data. Data can be biased. Data is incomplete. So because of that, we can say that unknown. What is unknown? Like data, like the training data is only a sample of reality. So there are many data points which are unknown. So this unknown will lead to uncertainty, because whatever ML model we will be making, it has to deal with uncertainty. It will be uncertain. Whatever predictions it will be making, whatever output it will be generating, it cannot be 100% accurate, because it is not trained. It is uncertain. It has uncertainty in it. So one very important point we can say, so whatever predictions we are making or our ML models will be making, they are never certain. Rather, they are only likely. Like whatever predictions ML models will be making, it will be like a probability. It will be likely that, okay, more than 80% of the chance is there that the email is a spam. So uncertainty is there. The element of uncertainty is there. Now I think you got a good feeling. And this is just one example. You take any example. You take any example. Let us suppose you are solving a real world problem. You are building a ML model. In that problem also, these things will be there, because the data you will be using will be incomplete. It will be having noise. It might be biased. So we have to deal with uncertainty. So uncertainty is something which is always there in machine learning. And now we got a feel of it. So now we'll discuss certainty versus uncertainty in machine learning. So if we talk about certainty, it is very rare in machine learning, because we already saw now, for a system to be certain, it should cover the entire population. Like the training should be done on the entire population. Like all the possible data set should be considered while training the model. There should not be any noise. There should not be any biasness. And if we are able to consider these points and train a model, then then also it can make mistakes. So certainty in machine learning will be hard coded rules. Like all the software development we have been doing since past so many decades, so they are based on logic. They are based on hard coded rules. If then, if this, then this. So all that, like we build algorithms and all, they are all deterministic. They're certain, because we know that, okay, if this is the input, this will be the output. So that is certain. So in the traditional software development, which we have been doing, we have been using hard coded rules, and that is certain. But in AI, but in machine learning, certainty is very rare, because in machine learning, it will be very rare that we will be using hard coded rules. Rather, algorithm will learn, because the beauty is that until now, in traditional software development, we have been telling algorithms how to solve a problem, because we know the solution and we just hard code rules for that solution, and problem gets solved. But the beauty of AI is that even we don't know how to solve the problem, and we just give the input and output. Like training data we will give to the algorithm will see that, okay, if this is the input, this has to be the output. If this is the input, this has to be the output. And with that mapping, it will on its own learn the pattern, and it will on its own devise the solution. So in AI, we will not be writing the solution. Rather, we will be training the models, and model will learn the solution on its own. And that is what is artificial intelligence is. What is intelligence? Intelligence is the problem solving capabilities. Humans are intelligent because humans can solve problems. And now machines are becoming intelligent. Algorithms are becoming intelligent because now no need for us to tell the solution to the algorithm. Algorithm will devise the solution on its own. That's the beauty of AI. So certainty is rare and uncertainty, it is default in machine learning. Because if we look at the spam classification example, like if we take an email, now that email can have some spam like features, and that email can also have, the same email can have some non spam like features as well. So because of that, because the same email, it is having spam like features also and non spam like features also. So there is always a uncertainty associated with the email, whether it's a spam or not. So our machine learning model, classification model, when it will classify the email to be a spam or not, it will not give a yes or no answer. There is no yes or no answer because we cannot say with 100% confidence whether the email is a spam or not. There is always a probability associated. Probability is associated with the output. So we say that 0.72 probability of spam. So for a given email, our machine learning classification model, it can generate output like 72% chance is there that the email is spam. So always chance is associated, uncertainty is associated because our machine learning model cannot say with 100% surety, with 100% certainty, it cannot say whether it's a spam or not. Always element of uncertainty is there. It's default in machine learning. So from here, one very interesting point we can discuss, like with all these discussions. So machine learning models, they do not give truths. So very important point I'm discussing. Always remember, whatever output you are getting from a machine learning model, that is not representing the truth, the ground truth, or the actual reality. So machine learning models, they do not give the truth. Rather, they give beliefs. So very important point we discussed. So the idea is that whatever output we are getting from a AI model or a machine learning model. See, I think the difference between AI and machine learning is clear to you. Machine learning is a subset of AI. When I talk about AI, AI is a very broad field. It contains so many advanced concepts which are far beyond machine learning. Machine learning is just a subset of AI. So whether you talk about AI or you talk about machine learning, so the outcome, the output of it does not give truths, rather they give beliefs. Because if I say that 0.72 is the output, like there is a classification model, I gave it an email and the output is 0.72. So the machine learning classification model, it is giving me a belief that there is a 72% chance that the provided email is a spam. So it is not giving me the truth value because it always gives the belief. So this is like a very important point to be considered, and we have to keep it in mind. Now we look at why uncertainty is the normal in machine learning. Because now see, we already got a feeling that what is uncertainty in machine learning, that we understood. Then we saw that uncertainty is something which is default in machine learning. Now the next question is why uncertainty is the norm in machine learning? Why uncertainty is a default in machine learning? So let us look at one example. So let us consider a medical diagnosis model. So medical diagnosis model, how it works is that it takes symptoms as input, and based on the symptoms, it will classify those symptoms into either disease A or disease B. So the idea is that, let us suppose I have symptoms for disease A, and let us suppose I have symptoms for disease B. So here will be the symptoms for disease B. Now, unfortunately, there will be overlapping symptoms. And what is overlapping symptoms? These are the symptoms which are for both disease A and B. Like symptoms common symptoms for both disease A and B. And this common symptoms, this overlapping region is introducing uncertainty. And why it is introducing uncertainty, let's try to understand that. See, the idea is very simple. Let us suppose I take any symptom from this region, then 100%, like, then a certainty is there that okay, if a symptom is falling in this region, then for sure it belongs to disease A. Similarly, if a symptom is falling in this region, then 100% sure that symptom is for disease B. So here certainty is there, but this overlapping region, it is causing the problem. And how it is causing the problem? Let us suppose if I pick a symptom from this region, then that symptom can be belong to disease A, or it can also belong to disease B. I am not sure about that. I cannot say with 100% confidence that okay, if this is the common symptom I have took from this region, I cannot say with certainty that okay, this symptom belongs to disease A or belongs to disease B, because it can belong to both disease A or disease B. So uncertainty is there. So this overlapping, it introduces uncertainty. And there are many scenarios, because if you are doing multi-class classification, or uh, like if you are dealing with many features, and that we deal in real world, whenever you are making a machine learning model, you will be dealing with hundreds of features or even thousands of features, and those features, they overlap. It's not like that they are independent set. Overlapping is there, and because of these overlapping, uncertainty is there. So this is like one very important point which we discussed about uncertainty in machine learning. And because of this uncertainty, machine learning models are probabilistic models. Probabilistic models. And one more very interesting point I will introduce here. This overlapping region is there, and we already saw noise will also be there. Some noise will also be there. And that noise will further create unnecessary confusion. It will further create uncertainty. So if we revise the points, if I talk about uncertainty in machine learning, why uncertainty is there in machine learning? So we already saw the reasons for that. The first is that data is incomplete. Like the training data is incomplete. It's a sample of reality. Noisy data, bias the data, all these contribute to uncertainty, and also this overlapping. So even the best model cannot be 100% sure. Like regardless of, like, let us suppose you made a state of the art machine learning model, the output of that will also be probabilistic. It will be a belief, it will not be a ground truth. It The output of the state of the art machine learning model, it cannot be certain. It is also like a chance. It cannot be 100% sure. So it can only express degrees of confidence. So even the best model can only express degrees of confidence. It cannot be 100% sure.